Now we are continuing with the bookstore example, and here we're going to look at what happens when you have more than one input. So suppose here we have uh, two products that we want to sell. Okay. Now let's assume that the numbers are the same. Okay. The cost and price and refund are all the same, and the demand distribution is PERT, and it's the same thing. Okay, so we can set up the distributions like this. So suppose we say round, okay, risk PERT, right? Minimum, most likely, and maximum. Okay. Now, since I have a round, I need to specify how many digits. So 0 digits. Now I'll go into edit mode, copy it, and paste it here. So you have the same formula here. Okay, so it's coming from the same probability distribution. And let me color code it as gray to indicate that that's the input, uncertain input. Okay, so light blue is certain input, this is uncertain input. Okay, now order quantity, again we will assume 200. Okay, so that's our decision variable. Okay, and then we have the demand, and I've added one more column this time as a return. So we set up one, and we can just copy it uh, down to the next. Well, I don't know that I can do that. I can't do that anyway. So now demand. Okay, so that's the demand for product 1. That's the demand for product 2. Okay, sales will be minimum of order quantity and demand for product 1 and product 2. Okay. Now return will be order quantity for product 1 minus sales, and order quantity for product 2 minus sales will give us return. Now revenue is going to be sales times unit price, and since the price is same for both products, I'm going to absolute reference it so I can copy it down. And cost, again, order quantity times unit cost. Okay, I can't copy this formula, so I'm going to, well, I'll copy the revenue down. Now cost here is product 2 times unit cost. Now refund is return times the refund amount. That I can copy, absolute reference that and copy that. And profit will be revenue minus cost plus refund. So copy that. And then add the two profits, that would be our total profit. So now I messed up the border, so let's put that back. Okay. So now we have probability distribution, the input here, and then the output over here. Okay, click OK. So now if we run the simulation as it is, then the demand for these two products are assumed to be completely independent. One doesn't affect the other. And that is one of the major mistakes that people make when they set up models, because the product demands often, especially similar products, okay, will be correlated either together, that is, if the demand for one product goes up and the demand for the other product also goes up together with it, or it may be opposite direction. If it is competing product, if demand for one product goes up, demand for the competing product may go down. So assuming that they are totally independent is not valid assumption in many situations. So to take care of, to handle the situation, at risk gives you a way of defining correlation between the input values. So we have two input values. So the correlation is going to be a 2 by 2 matrix. And we can set up a 2 by 2 matrix and then say, all right, the correlation is going to be, we'll assume that it's going to be this or this or this or that. So we can try different values of correlation and then see if they are very highly correlated, what will be the profit. If it is not very highly correlated, if it is positively correlated, negatively correlated, and so on. And we define that by going into, okay, so select the product, then the one of the cells with the input, okay, and then you do correlation. So here for correlation we have three possibilities. We're going to define correlation matrix, and then there is what is called copula. Copula is nonlinear correlation is what is copula. Okay, so correlation is linear correlation. The correlation between the two products will be linear. So let's do define correlation matrix. Okay, and then you need to specify which input variables you want to define the correlation for. So you can have any number. So if you have 10 products, and you'll have 10 input cells, and you'll have a 10 by 10 correlation matrix. But here we have a very simple example. So there are only two products. So we highlight those two products. All right, and then click OK, and then that opens up a matrix where of course the diagonal is going to be 1, because diagonal will be product 1 versus product 1, product 2 versus product 2. So that is correlation with itself is going to be 1. So it is the off diagonal, okay, is going to define your correlation, and this will be the correlation between product 1 and product 2. Of course that's going to be the same there, so that is grayed out. So you have only values below the diagonal. Okay, the default value is 0, and we will be able to change that. What if it is not 0, if it is something else? Okay, so now we need to insert this correlation matrix somewhere. Okay, and then so you click OK. It's going to tell us, ask us, where do you want the matrix? Give me the first cell. So now it inserts a correlation matrix. Not only that it inserted correlation matrix, remember when we defined this, we said these are the two cells for which we are defining correlation matrix, and you see that at risk is inserted. See, we only had risk part, right? So now it has inserted the risk core mat function into it. So it says, okay, risk core mat from the new matrix, when it automatically gave a name for it, we could change the name if we wanted. So you take the correlation from the matrix, and it is the first product, product 1. So if you go to the second one, it will say, okay, this is the correlation comes from the same matrix, but it is, this one is the second product. So now these two input cells have been linked to this correlation matrix, with correlation coming from here, and product 1 being that cell and product 2 being this cell. Okay. Now if you run right now, so there's only 0, so it's going to be exactly same as before. Correlation is 0. They are not correlated at all. What we really want to do is to try different correlation values. Say suppose we want to try 3 different correlation values. So you set that up. Say we want a negative value, okay, then no correlation, and then a positive, highly positive value. Okay, of course, this is something that I have just come up. You can have a list of possible correlations, not just 3. You can have 5, 10, 15. And then use the risk sim table function in here, where you'll tell at risk that try these 3 different correlation values, and for each of them run the simulation, right? So here we need to go and set up risk sim table. Okay, and the values must come from here. Okay, so now with correlation, now we have 3 different simulations, right? 1, 2, and 3. The correlations corresponding with those 3 simulations are these. Okay, and we've defined the output. These are the input and correlation. So now we are ready to run. Again, we need only 3 simulations, but since we ran 5 here, we'll leave that at 5 and we'll run the simulation. Okay, we're done with the simulation. Okay, so now we can set up output values, say risk min, okay, of what? Of the total profit. Let's make it absolute reference for simulation number 1. And 5th percentile, risk percentile of profit, press F4, and then the percentile we want, and the simulation number. Then we have risk mean of profit, F4, for the first simulation here, and then risk percentile, total profit F4.95, and the first simulation. And then we can do risk max profit F4, and then the first simulation, and then the standard deviation, okay, of profit. So press F4 and the simulation number. Okay, now they're all dollars, so let's change the format to dollar. Let's get rid of the decimal places and copy that over. And now we get the simulation results for the cases when highly negatively correlated, highly positively correlated, and then no correlation at all. So when they are negatively correlated, usually loss in one is made up by profits in another. So there is mitigation of risk, so there is more less standard deviation, and then you have an even distribution. When they are highly correlated, so if one demand goes down, the other goes down as well, and therefore the risk is higher. You have minus 470, and then your standard deviation is very high as well.